To compute the mean and the standard deviation of an ungrouped data, we use the following formulas. The variance, which is also denoted by x squared or sigma squared, is computed as the summation of x minus the mean all squared divided by n, where n is the number of points. And this formula is the same as summation of x squared divided by n minus summation of x on n all squared. And as we already know, sigma x on n is the same as the mean, so which is going to give us the formula on the far right, which is summation x squared on n minus the mean squared. Also, to compute the standard deviation, we just have to take the square roots of the variance, which is the square roots of what we have here. So that's going to give us the square roots of sigma x minus mean all squared on n, which is the same as the one on the far right. Let's consider some examples on finding the variance and standard deviation. We start with finding the variance and standard deviation for ungrouped data. Example 1. The marks obtained by 5 students in a quiz are 12, 15, 17, 20, and 16. Find the variance and standard deviation. By definition, the formula for finding the variance is defined to be summation x squared on n minus the mean squared. So it's important we find the mean. So the mean is also defined to be sigma x on n, and thus we are going to have 12 plus 15 plus 17 plus 20 plus 16 on n, where n is the number of points, and so here we have n to be 5, and so our mean is 16. Our next step is to compute sigma x squared. So here we have n to be 5, so we are going to have summation I running from 1 to 5 xi squared. That is going to give us x1 squared plus x2 squared plus x3 squared plus x4 squared, then plus x5 squared. So here x1 is giving us 12, x2 15, and so on. So thus we are going to have 12 squared plus 15 squared plus 17 squared plus 20 squared plus 16 squared, and this is going to give us 1314. And from above we have our mean to be equal to 16, so we can now compute our variance. So the variance is defined to be summation x squared on n minus mean all squared, and we have summation x squared giving us 1314, so that's going to be 1314 divided by n, and n is 5 in this case, minus the mean is giving us 16, and so 16 squared, and this will give us 6.8. Hence our variance is 6.8 units squared. Now let's find the standard deviation. The standard deviation, denoted by delta or x, is defined to be the square roots of the variance. So thus we are going to have square roots of 6.8, and this is going to give us 2.6076 units. Let's try our second example on finding the variance and standard deviation for ungrouped data. So you can pause the video, then you try your hands on this question. After that, then you check if your answer is the same as mine. The question is stated below. A factory produced the following number of items in 7 consecutive days: 28, 32, 35, 30, 25, 40, and 45. Calculate the variance and standard deviation. So as we saw in our previous example, we need to find the mean. So the mean is defined as sigma x on n. So in this case, n is given as 7 because we have 7 points here. Now we add the terms, so 28 plus 32 plus 35 plus 30 plus 25 plus 40 plus 45. And this is going to give us 33.571. We now calculate sigma x squared. So here n is 7, so we are going to have summation I running from 1 to 7 xi squared. So that's x1 squared plus x2 squared plus x3 squared till x7 squared. So in this case, x1 is 28, x2 is 32, x3 is 35, and so on. And thus we are going to have 28 squared plus 32 squared plus 35 squared plus 30 squared plus 25 squared plus 40 squared plus 45 squared. And this is going to give us 8,183. And so the variance will be giving us summation x squared on n minus mean all squared. That's 8183 on 7 because n is 7 minus the mean, which is giving us 33.571 squared. Computing this, we are going to have 41.988 squared units. Then the standard deviation will be giving us the square roots of the variance. So that we're going to have the square root of 41.988, which is going to give us 6.4798 units. Now let's prove that this formula is the same as what we have on the far right, and we also do the same for the standard deviation. From binomial expansion, we know that a plus b all squared is equal to a squared plus 2ab plus b squared, and also a minus b all squared is equal to a squared minus 2ab plus b squared. So we are going to use the same idea to prove that the formula on the far left is equal to the one on the far right. So now let's take what we have on the left side. That's summation x minus the mean all squared divided by n. So since n is a constant, we can factor it out. So that's going to be 1 over n out summation x minus the mean all squared. So now note that this expression is similar to what we have here. So now let's expand this guy. So expanding this is going to give us 1 over n summation out x squared minus 2x times mean plus the mean squared. So now let's simplify. So we cannot distribute the summation sign through, so that's going to give us 1 over n summation x squared minus summation 2x multiplying the mean plus summation mean all squared. So here we should know that we are summing from 1 to n. So since 2 is a constant in the middle term, we can factor out 2. So that's going to give us 1 over n into brackets summation x squared minus 2 summation x times the mean plus summation mean squared. So we now distribute 1 over n, so that's going to give us summation x squared on n minus 2 on n summation x times the mean plus summation mean squared on n. Let's focus on the summation in the middle term. Thus we have summation x multiplying the mean. So here we should know that the mean is a constant, right? That's a fixed number. So suppose we are finding the sum of summation 3xi, I running from 1 to n. So we are going to have 3x1 plus 3x2 plus 3x3 till we get to 3xn, right? So we have 3 here, 3 here, 3 here, 3 here also. So now we can factor out the 3. So that's, you're going to have 3 out, then x1 plus x2 plus x3 up to xn. So that's, we can rewrite this as 3 summation xi from 1 to n, right? That's when we have a constant in the summation sign, we can factor out the constant. So in this case, the mean is a constant, right? So we can factor out the mean. And so we are going to have summation x squared on n minus 2 on n mean out, then summation x plus summation mean squared on n. Then thus we are going to have summation x squared on n minus 2 times the mean summation x divided by n plus summation mean squared on n. So here we should know that summation x on n is the mean, right? So we are going to have it to be summation x squared on n minus 2 times mean, and this is also going to give us mean, so that will be times the mean again plus summation mean squared on n. Thus we are going to have summation x squared on n minus 2 mean squared, then plus summation mean squared on n. So here let's focus on the last term. So we have it to be summation mean squared on n, which is the same as 1 over n summation mean squared. So we know that the mean is a constant, right? Let's assume that the mean is equal to 2, which implies that the mean squared is going to be 4, right? Or 2 squared. Now let's add 2 squared n times and see what we are going to have. So we are going to have summation 2 squared I running from 1 to n. That's, we are going to add 2 squared n times. So we are going to have 2 squared plus 2 squared plus 2 squared till the nth time, that's 2 squared. And so we can factorize 2 squared out. That will be 2 squared. Then to be left with 1 plus 1 plus 1 till the nth time. That's, we're going to have 2 squared. So 1 plus 1 plus 1 to the nth time is going to give us n, right? So our summation will just be 2 squared n. Thus this expression is going to be 1 over n, and as we saw, summation mean squared is going to give us n multiplying the mean squared. Now this n will cancel out this n, and so we are going to have just the mean squared. And so this expression is going to give us mean squared. Thus we are going to have summation x squared on n minus 2 mean squared plus mean squared. So this is going to give us summation x squared on n minus 2 mean squared plus mean squared is going to give us minus mean squared. So we can either use this formula to compute the variance, or we can use this formula to compute the variance. So same holds for the standard deviation. That's when you take the square root, so we will just get the same expression. I hope this video is helpful. Make sure to subscribe and like. See you in the next video. Bye.